Good morning, everyone. I'm going to give everyone an opportunity to carry on filing in before I get us started. Thanks for joining this morning. Alrighty, I think we have a pretty good number with that. So good morning and thank you for joining us today for Hatchery 101 Master Your Monitoring, a 60-minute webinar sponsored by Oxyguard Pacific. I'm your host, Shahalis Newbound, Digital Media Coordinator at Annex Business Media, publishers of Hatchery International Magazine. Today's webinar features a panel of industry experts ready to share their ideas and techniques to building and maintaining an optimal environment in your hatchery. It's my pleasure to introduce our panel's moderator and someone you may recognize if you've attended a previous Hatchery 101 webinar, Ron Hill. Ron is the founder and CEO of Velocity Aqua and has a strong background in hatchery operations, aquaculture education, and aquaculture content. Before we begin, I'm just going to take a few moments for some housekeeping items. Today's webinar is being recorded, and a link to the recording, which will be closed captioned, will be sent to everyone who registered in 24 hours. If you have any questions for our panel during the webinar, please type it into the Q&A box located at the bottom of your screen. We will do our best to get to every question today. Now, without further ado, I'd like to turn it over to Ron.
Hello, everybody, and welcome to the third installment of the Hatchery 101 webinar series, Master Your Monitoring, brought to you by our friends at Oxyguard. Water quality monitoring is of the utmost importance to any farmer raising aquatic species. The ability to monitor and maintain the quality of water, allowing species to thrive, is one of the biggest challenges facing farmers. What constitutes optimal water quality is very species and life stage specific, but there are many husbandry principles in common. For the first portion of today's webinar, our panelists will each have the opportunity to answer a series of prepared questions on water quality monitoring. The second part of today's webinar will feature audience questions for our panelists, so please write your questions into the Q&A as we go. Today, we've brought together an excellent panel of 3 industry experts to share some of their knowledge and experience with water quality monitoring. Our first panelist is Pa Peterson, CEO of Oxyguard International. An electronic engineer by trade, Pa specializes in the measurement and control technology. He serves as the technical manager for the design, planning, and manufacture of many Oxyguard measuring, monitoring, and control systems for aquaculture. Our second panelist, Dan Painter, served as the general manager of Halibut PEI and followed that up as the general manager of hatchery operations for Atlantic Aqua Farms, the largest grower and producer of Prince Edward Island mussels. Dan currently serves as animal resource manager at Atlantic Veterinary College at the University of Prince Edward Island. Our third panelist, Dr. Steve Pollock, is the owner and operator of Triple N Oyster Farms. Dr. Pollock completed his PhD at Louisiana State University and was a postdoctoral fellow at Stanford University studying microalgae response to changes in their environment. In 2015, Steve started his own oyster farm in Grand Isle, Louisiana. In 2017, he started an oyster nursery, and in 2019, followed with an inland oyster hatchery using artificial seawater in a recirculating aquaculture system. Without further delay, we will jump right into the first question. Please give us a little background about yourself and your experience with water quality monitoring, and please let us know what you think the most essential water quality monitoring parameters are and what the best method is to monitor that. Our first answer goes to Pa.
Yes, thank you. I've been growing up on a big Danish eel farm. My family had a big RAS eel farm. And I've been in Oxyguard for over 25 years. Around the world, setting up farms. I'll probably see plus 400 farms setting up equipment for Oxyguard. So it's a lot of farms through the time. The most important parameter, oxygen. stop feeding your fish or stop giving them oxygen. You see what they die of first, you can say. And temperature, pH, alkalinity, and so on is also important, of course. But if we look into oxygen, there are two ways you can measure oxygen today. You can use what we call electrochemical cells, also names as galvanic cells, or you can use LDO, called optical. Those probe, you can say, in that kind of technology, there are probe that definitely works very well, but there are also probe that doesn't even measure oxygen. So it's very important that your probe is giving the correct value. So if you compare the two technologies, you can say if you take the both on both sides, there should be you say there's a technology distance between the price of them. You can say on an oxygen probe that is with galvanic is probably 3 times cheaper than one with optical principle. But from Oxygard side, we don't care. We have both. We claim we have the best technology in both technology. So we let it up to the customer to decide which one he wants. Just remember that oxygen management is very important to the correct directly to your FCR, your bottom line, because if you don't measure correct, you will see it immediately. You either use too much oxygen or too less oxygen, and you don't get the right feed conversion rate. So oxygen is a very, very important parameter. But again, if you don't buy the probe from us, we're buying them at least from somebody who's reliable, that can measure, supply probes to other industry, nuclear or something else, where they can measure 1,000 less, because then you're sure that the measurement is correct. And an oxygen measurement should always show 100% saturation when it's in air. So of course, all the parameters is important, but oxygen, you have to start with oxygen.
Dan, up to you. What do you think?
Yeah, thanks, Ron. Thanks for having me here today. I grew up in a fishing family, so I mean, I've always been attached to the water in some way, but I'm kind of the black sheep for not catching fish, but instead raising them. And so after I got a biology degree, I moved into aquaculture, started out as a technician and just kind of learned the business all the way up through. And after a decade with halibut PEI, I moved into shellfish. And after a short period of time there, I've now moved into the academic world, where I do still have an aquatics facility. Under my guidance, I also have large terrestrial facilities as well. So while my responsibilities have widened a bit, I still have that passion for aquaculture and intend to, keep my finger on the pulse of that industry as much as possible. So I love the people there involved in it, and you won't find a more caring and determined group than aquaculturalists. So glad to still be a part of the group. In terms of your second question, I think you started out with the right panelist, because everything Pa said is absolutely accurate. He is certainly the expert in that technological sense. I can't provide anything there, but from a management perspective or a people husbandry perspective, I think just knowing your animals is the most important thing. Obviously, different species have different requirements from, saltwater, freshwater, recirc, flow through. There's so many differences from site to site. Even you really just have to know your facility and how your animals react to certain situations. So, I mean, people like Pa and other groups around the world can provide us with the technology we need for monitoring, but it's our job to train our people to respond to the animals and really know from a day-to-day what sort of water quality they require, and just kind of where your boundaries are.
Thanks, Dan. Steve, what's your perspective?
So specifically for water quality monitoring, there's two main aspects that we look at the hatchery. And I just want to mention before I talk about monitoring just a little bit that we kind of have this triangle that we think about, where it's a 3-faceted ordeal, where we have brood stock coming in. And for oysters specifically, egg quality is a massive determinant of how successful you may or may not be in the 14 days that follow. If egg quality is good, then you need to look at your food quality. We grow our own algae at the hatchery. It's one of the ways that lots of bacteria can get in the tanks. And so if you don't have good food, if you don't have good brood stock, it doesn't matter what you monitor in the water. And that was something I learned the hard way. It is basically chaos. When you throw your fertilized eggs in that tank, if those eggs aren't good, it doesn't matter what you do. There's a good chance you're not going to produce anything in that 2-week time. The water quality monitoring part, for us, it's not just about chemistry. We do standard bacterial testing on a regular basis, especially when problems rear their ugly head, which is more often than I ever would have guessed in operating this inland closed recirculating aquaculture system. I'll just mention one cool thing about the monitoring. We start with city water, which is extremely rare. We start with city water, and then we add a commercially available artificial seawater mix to it. We can set the salinity to whatever we want. We monitor individual elemental composition using ICP analysis. And over time, we can see certain elements drop in concentration in our system, and we can then bring those levels back up again. And we find that we can see that more so than in the oysters. We can see that in our algae growth as well. When those micronutrients do go lower than where they need to be, our growth does slow quite a bit for the algal cultures, a difference of days in harvest time. And so, as the last gentleman just mentioned, sorry, I'm terrible with names, there's a lot of husbandry that's taking place when we're doing this for the food, for the brood stock that we maintain in the hatchery and artificial seawater, and then the larvae in the tank. Every day when we have larvae in the tank, I take a flashlight and I flash it in the tank and I look at the larvae. You can see them, even though they're really small, and you can get a feel for how healthy they are, whether some have dropped out to the bottom and died, which occurs far more often than anybody's really wanting to admit. And as I mentioned before, building the hatchery, controlling every single parameter that you think you can control doesn't always guarantee success. And so water quality monitoring is one of those things that I'd rather not have to do ever, but it's just the reality that we have to check things like pH. Salinity doesn't change at all. Oxygen concentration actually doesn't change at all in our hands. We're always pushing 95% saturation. And so we've actually stopped monitoring oxygen as a regular component, even though it's really easy. It's just one of those things that we've never seen a massive change in the oxygen concentration in the water. So just real brief, I don't want to talk too much. The husbandry part, I think, is the key part that comes back. Before I did this, and I have life science training out the wazoo, PhD, postdoc, doing PCR, special techniques. I thought come into the hatchery, you can control everything, just like a PCR experiment, where you can change one little constituent in that water chemistry. The reality is it's almost impossible to do that in a hatchery setting if you're trying to commercially produce. Researchers and academia do try to produce results, but there's a lot of possible variants coming in already. And so water quality monitoring is one of those things. And as I mentioned, it's not just about water chemistry for us. There's a lot of problems with bacteria, with fungi, not so much with viruses. And so we've done a lot of genomic analysis of our water as well to try to figure out what we have in our water. And it's just one of those things. It's just chaos. But I'll leave it at that and let the questions come.
Thanks, Steve.
You're welcome.
Question number 2. What does water quality chemistry tell you about your stock, and how can you use the information you gather to manage your animals? First to you, Dan.
Yeah, so I mean, simply put, the water quality is going to tell you the health and welfare of your animals, and sometimes that can be interpreted as an emergency, but really from an optimal growth standpoint, you don't just want your animals to survive, you want them to thrive. And so optimal water quality is really necessary for the stress levels of your animals, not just the health. And I mean, it can come down to seeing how fast the oxygen drops after a feeding session, and perhaps that influences you to have more feedings per day rather than 1 or 2 large feedings. Or another example of CO2 or pH, however you want to monitor that, you can evaluate the densities of your tanks and how acceptable they are. So it really does allow you to plan for the animal's best optimal situation, living conditions. And from a management standpoint, the more data you're gathering about your water quality, the more trending you can see. And so your decisions become predictive rather than reactive. And I think that's the place where a lot of farms need to get to, is that the natural situation you find yourself in, whether it's due to cost or time, is that you're seeing situations happen and then reacting to them. And usually by that point, it's too late. And so if you can get something in like a 24-hour monitoring system, you can really start to make more informed decisions ahead of time to avoid those situations.
Steve, up to you. How does the water quality chemistry, what does it tell you about your stock, and how do you use that info?
So Dan made the comment that it lets you know the health of your what you're trying to grow. In our case, we're trying to go from fertilized eggs about 50 micrometers in size to an oyster larvae that you're ready to set at about 320 microns in size. And that's what we deal with here in the inland hatchery. And I feel that as we look at these, we drain them down every 2 days in the tanks, we clean the tanks, we bring the water back in, and then we put the larvae back in there. When we do that, we measure the size of the larvae. We look at counts of the larvae to see if we have mortality in those 2 day periods. And if we have more mortality than we expect or slower growth than we expect, then we start asking questions. I know that's opposite of what Dan just said, but in the oyster hatchery business, that's pretty much how that works. And now, having done it for a few years, I truly understand why. Because the major parameters of the water quality, they're standard. pH doesn't change, especially in my system. Oxygen concentration doesn't change. The alkalinity doesn't change. We only have at most, at the end of the 2-week period of growing the larvae, a handful of grams of oyster larvae in a 1,000-liter tank. So we don't have to deal with the waste that you deal with in growing out shrimp or fish. So our water, when we actually get the dirty water out of the tank 2 days, it might have a little bit of a green sheen to it. And then we go through our filtration, which is very, very simple. And it's crystal clear already in our system. And so water quality isn't something that we actively measure on a daily basis unless we see there's something awry. And related to that, there's bacteria. I'm going to come back to bacteria quite a bit. I think most of you have heard of Vibrio before, right? Vibrio is nasty. There's some that can make people sick. There's a lot that actually prey on oyster larvae. And if water chemistry is out of whack, if food quality is out of whack, if egg quality is out of whack, Vibrio will take advantage of that as an opportunistic pathogen. It's there even when your broods do perfect and everything follows great. You have good water quality, you have good brood, good larval development and growth. There's still Vibrio in there. It's just when something happens to stress them out, Vibrio can infect them and cause crashes. You'll go home in the evening, look in the tank with the flashlight, everything looks great, everything's growing and developing as it should. Come in the next day, everything's dead on the bottom. And that can happen over and over and over again until you figure out which one of the multiple different possible components are off in that system. And overstocking, as Dan mentioned, is one of the major issues that a lot of the young hatcheries have. They say, oh man, I've got all these fertilized eggs, I'm not going to throw them out. Put them all in the tanks, and that stresses them out. And then they die from that. And it's really a bacterial issue. And so I'll speak more about bacterial monitoring later, but bacteria are central in these oyster larvae. They're extremely sensitive to every single chemical, biological parameter that you can think of.
Paul, you want to give us your thoughts?
Yes, I would say, as we already can hear, it really depends on the farm design and the species you're raising, you can say. So there's a lot about that. Is, are you a closed farm? Have you open outdoor farm and so on? So, but I would say it's more about creating the right environmental for the animals you are raising, you can say. So that is the water chemistry is just telling you have the right water, you can say, and then of course healthy animals, and then you are on the right track, you can say. But everything can happen, you can say. Then you have to have UV, ozone, whatever into your farm so you can control the bacteria and so on. That helps you. The right biofilters are big enough and so on. So it's all about the design of the farm and say. And then yes, it is. In fact, it's the environmental around the animal we try to create, and that is what we're monitoring. If we first can monitor and see there's something going wrong in the water, you can say there's something wrong with the design, maybe.
Thanks, Bob. Question number 3, first to you, Steve. You touched on this briefly. How do you decide how frequently to monitor? How do you choose your interval, be it daily, weekly, multiple times a day, or real-time monitoring?
So as far as a consistent monitoring schedule, we do the ICP analysis on a fairly regular basis. Every 2 or 3 months, we send samples out for testing. Bacterial monitoring, it's pretty much on an on-needed basis. If we see something's awry with the growth, either of the algae and or of the larvae in the tanks, we'll start doing plates, both for just general microbial population density and specifically for Vibrio. We use a plate that's referred to as a TCBS plate, and it's very specific to the growth of Vibrio and a few other organisms. And we can get general numbers, even though we're using ozone and UV. The broodstock system is just, it's full of all sorts of organisms. It's impossible to keep it out of the system. So we do monitor the broodstock somewhat, as well as a completely quarantined system from the larval rearing conditions, but that water chemistry remains fairly constant. We do have some overflow as we feed them roughly 30 to 50 gallons of larvae a day. And so we move that water out to drying containers that are covered in the shade, so we can actually throw that out without causing issues with the EPA or the other environmental government agencies down here. But in general, for example, when we measure ammonia, nitrite, and nitrate, we have 0 ammonia, 0 nitrite, and 10 parts per million nitrate in our system. And so our water is just exceedingly clean. As far as if it was a fish farm, I think people would look at it and say, what the heck are you doing to keep your water in this shape? And we just don't have the biomass issues that the fish and the shrimp people do for grow out. And so regular monitoring, I don't want to say we don't do it at all, but it's definitely something that is oh crap, what's going on sort of knee kick response of, okay, let's go and see what's going on. And usually it's never something big. It's not oxygen, it's not pH, it's not alkalinity or calcium content, hardness in the water. It's something that's much harder to determine. And I think that's because of the active biological component in the system.
Pa, what are your thoughts on interval?
Yes, as you already can hear, it really depends on what species you have in your farm, you say, and of course, it's also depending on the parameters. Oxygen can change in seconds, pH change slowly. So yes, again, it depends on what are you raising, what kind of value you're looking at, the value of the fish. Just to mention that, if the stock density in that tank have a high value, you should definitely measure the oxygen in there. If it doesn't have a high value and you know no risk that you will lose the oxygen in there, and then you don't need that measurement, you say. And then it's management. That's what get the farm going.
Dan, you want to add to that?
Yeah, I think I agree with everything that's been said thus far. I mean, one thing that we always practiced with our facilities was kind of studying the system in different scenarios and then acting as the system demands. So if you're starting up a new system, maybe you're measuring 24 hours a day, and maybe you realize that it doesn't change over the span of a week or over the span of events. And that's when you can cut back and kind of reduce to where is required. But obviously, like Pa said, it's the value of what you're measuring is important to weigh, you know, the risk versus the urgency versus the cost. It's no different than any other business decision. It's how much is at risk at the time and what you need to do to mitigate those risks.
For our fourth question, it seems like a simple one, but I always find that there's a lot of variation in the answers. Where do you take your water samples and measure your water quality from a tank of organisms, and why? First to you, Pa.
Yes, I don't know if I'm the right person to talk about that, but I would say that again, this depends, of course, what you can measure. Can you measure it online, or do you have to take it out water samples? It's often something to do with the measurement. What does it cost to have this measurement? There are some measurement that is quite fairly cheap, like oxygen, pH, and so on. But ammonium, nitrate, maybe not possible to measure, or it costs you a lot to measure that, you can say. So it's better to take samples once in a while and send them in for check. Maybe you're not even know what you're checking for, so we already heard that. So you have to send them in for further analyzing and so on. So I think it's a quite difficult question to answer just like that, because it's also depending on, have you any issues? As we already hear, if you don't have any issues, there are no reason really to measure it, you can say. But if you have issues, you have to start to find out what is causing the problem you have.
Dan, to you.
As a general rule, for most parameters, we would measure at the outflow of a tank housing animals, and usually that's just assumed to be the point of worst water quality. But again, learn your system, measure all around different areas of the tank, depths, what have you, to see the consistency, to learn what the discrepancy is between areas. Another big thing, of course, in research is learning the effectiveness of your equipment, and water quality can tell you that. Doing point samples at different locations of your system, whether that's immediately before and after your mechanical filtration, immediately before and after your biofiltration, that can teach you a lot about the effectiveness of your system, and if there's minor tweaks or improvements that you can make in that. So I think, again, it's just a gathering of knowledge, especially if you have the ability, whether it's the manpower or the technology to do so. The more monitoring, the better initially, and then after you realize where your consistencies are, then you can kind of cut back from there.
Steve, do you want to give us your perspective?
Yeah, I'll be quick. The one thing I just want to throw out there as far as location goes, we have 6,000 liter tanks that we use in my hatchery, and it's almost always the case that all 6 behave somewhat differently. And the chaos that we see in that, and trying to determine by doing various testing, mostly biological, but some chemical of those tanks, is we're looking for trends. We're just looking for trends to see if we can correlate anything with something. And unfortunately, in the majority of cases, if we find a trend, we then need to invest time and energy to actually determine if that trend, whatever we're seeing, that may be leading to differences in those, one tank doing much better than another one, crashing out completely, but not the others. It becomes an economic question as well. You don't make money when you're doing these tests. I'm not an academic anymore. I was in the past, but if I'm trying to sell these larvae at the end of 2 weeks, I don't really want to roll into a research and development role and not produce anything for several weeks at a time to determine, oh, this was the one difference. I only sold the 4 tanks. I didn't sell the other 2. And now I need to change everything, which is unfortunate, but it's just the way things roll. We need to make money as a company. And if we don't make money, well, I won't be here talking about this probably next year or the year after. And so where do we test? We have 5,000 gallon sump tanks that we have outside, 3 of those with pumps running them constantly with biological filters. And so when we have issues, we'll actually take samples from those 3 tanks. The last tank in line is what we call the polish tank. It has a 400 watt inline UV lamp on it, continually going. It generally has the lowest bacterial concentration in the water column. We test the pipes throughout the hatchery where the water flows in to see if we need to clean out our pipes. We'll do an overnight bleaching of the pipes, followed by neutralizing of the bleach and cleaning out as much we can. And then that does help, but it's just one of those mitigation types of things where we do some of those things routinely, and we do test afterwards just to make sure that we are mitigating, especially the bacteria coming into the system. So to answer your question, when we have a problem, we probably test every possible different isolated tank within the system to see if there's something awry somewhere in the process of cleaning our water, because we reuse as much water as we can in the hatchery. Some of the water we've been using has been in our system since January of last year of 2021. So just to give you a feel, we test everywhere if we can.
Ron, I just want to add to that that of course in the fish they always measure central around the filtration system, and then of course at the outlet of the tank, depending on how the mixing of the water in the tank is.
Okay. Question 5. You guys all kind of touched on this just a little bit. With the great expense attached to a lot of water quality tests and equipment, how does a farmer balance proper monitoring with the need to be cost effective? First to you, Dan.
Yeah, that is the ever-present balancing act that we find ourselves in. I mean, it's just experience, again, with your own species, your system especially, but even the people. I mean, if you're going to have a consultant come in and tell you what you should be monitoring, they'll probably sell you 10 of each kind that they have, and it's probably not necessary. And so what you'll soon learn is by adding more monitoring, adding more alarm points, you're also adding more cumbersome activity for your staff, more emergency calls, things like that, and those do add up in cost. And so while you are already paying your staff, the time you're losing for them reacting to an alarm that may not be necessary is a huge loss, and not just to the books, but to the mental health of your team. If I can recommend anything, it's to eliminate nuisance alarms. Know what the requirements are for your fish or your shellfish, and respond when needed and not more than that. So it is difficult to find that balance. And I mean, I've experienced working in a facility that we could struggle to keep the lights on from month to month, and we were doing our best with the little means we had. And I also have experience with a place that had so much that buying a new monitoring probe or sensor system, no one would blink at. And so there's certainly a balance to be found there. And it's just, experience is the only thing that I can attribute it to.
Steve, do you want to touch on this a little more?
I'll just say all the monitoring does cause problems. The research and development part of the operation does cause problems. This is I don't know if you guys can tell, but this is the year I'm losing my hair. This is something that definitely is always in the back of your mind, is like, do I need to buy this? Do I need to test this? Oh, someone suggested it might be this. Maybe I should start testing that. And then you see a trend where it's different and you end up spending a lot of money, where most of the oyster hatcheries in the industry just throw everything out, clean everything up as best they can, start back up, and never know exactly what went wrong. I don't know how true that is for fish or shrimp grow out farms and RAS systems around the world, but that's something that's commonly seen amongst the oyster industry, that it's just so hard to put a finger on something. It's never something big. And so spending on monitoring systems, yeah, it's nice to have. It's cool. You can generate graphs if you have grants to do the research. I have a USDA SBIR grant. They like to see graphs over time. And if you have the monitoring equipment, you can produce these graphs and say, hey, look, I monitored this, and at least show that, yeah, there were no significant changes. But beyond that, as far as production goes and making money, you really gotta put the nails in, and you gotta go, and you just gotta produce. And if you don't produce, like a lot of the hatcheries have done around the United States, well, you go bankrupt. And so it's a really, really hard line to place. How much do I invest in monitoring? There's a lot of hope in this industry, and it's a shame that it's not an industry that you can go in and actually put your finger on. Why are we having problems? And if I can just add real quick, hatcheries that do well, they do great, but coastal oyster reefs around the world, not just here in the United States, but around the world, have really been suffering. And that's another example of monitoring in the environment. What are we monitoring? What are we putting our finger on? Global climate change / warming, ocean acidification. There's a lot of correlations out there, but I think the honest truth is we do not know what's going on in the natural system. So I was hoping coming into my closed recirculating aquaculture system, I could control every single variable and it wouldn't be an issue. So that short answer to the question is, yeah, we can spend thousands and thousands of dollars on monitoring, but actually making those correlations isn't a reality, I think, in the situation of a oyster hatchery, not grow out, but hatchery, where you're dealing with these organisms that are ultra sensitive to changes in their environment. Let's stop there. Talk too much.
Paul, what are your thoughts?
Yes, I don't know if I'm to blame for this question here, but just by enough. But no, to be honest, I have been there myself, going into a farm, and they are completely silenced. That alarm you would like to have when you go out, and you, just because of water level somewhere, and you've been up 4 o'clock in the night and so on, you're just sick and tired of the system because it gives you a false alarm. So it's very important that the system is reliable and you only make the system you need. I completely agreed on that. And then you should buy a system that is module built. because if you have a system that is model built, you can add on, then you can start with something small, and then you can add on it later if you need it. You can say, but if you have bought something that you cannot build on, then in fact you lost all the money you already invested, because next time there's a new generation, there's something extra, the smart salesman come and say, okay, you need this and this and this, and you will buy again, but you already lost the first investment. So it's important that you buy something that you can build on, and that you buy from a supplier that you can be quite sure will be able to service you. We have systems that have been, they're still in operation, that have been out there for over 25 years, and we can still support them. So a monitoring system can easily hold at least 15 years or more. You can say, so you should look into the investment, even it costs you a little bit more in the beginning that is model built, but you will gain itself later.
How do you keep a monitoring system working properly to ensure that all probes, sensors, test kits, and equipment are working in optimal fashion and giving you accurate numbers? First to you, Steve.
So I'll answer the accurate numbers part. We use a Hawk spectrophotometer in my lab. We use it very rarely, but it actually auto calibrates. And if there's ever a question about whether there's a mistake in the program, we just mix up our own ammonium chloride or various compound and just test it. Same thing with the oxygen probe. We just test it. Oh, in open air, I think somebody mentioned this already. You should get a measurement of 100% saturation in open air, and you can actually, I can't remember the name of the compound I use, but you can add a chemical compound to the water that pretty much scrubs all the oxygen in the water, and you should see that oxygen probe drop down close to zero. Actually, I think it's about 2% or so, but we'll just double check using standards. I think that's the main thing. As far as upkeep, you should be following whatever schedule is there, checking the probes, make sure they're clean, etc. But like I said, it's not something we do intensely at my hatchery.
Paul, what are your thoughts?
Yes, you can say a system, you say mainly when you have the probe online, you can say no system is better than the management you do with it, and keep it clean. You have to go out and wipe the probes once in a while. Nearly all the probes need to be wiped for bacteria that grows on them, or either use or produce whatever they are doing, you say. And we see more and more start to talk about automatic cleaning on the system, you say, and we can you can easily supply that to the system, you say, but still you have to go out and check your sensor system, because if you rely on the system, it's something about sleeping tight at night, you can say, and somebody have to check it. You can say, do you trust the oil lamp on your engine on your car? You can say, so you have to check the probes once in a while, especially if they're online. And if you go up and wipe them, it is also a good time to also to check that the probe in fact is working, you say. And oxygen easy, you can say pH, you can do it, pH radar and so on, you do with buffer and so on. So check them once in a while. I will at least recommend that I would say our custom do it once a month or every 3 months. Once a quarter, you need to check your system, because it's a high value of fish you have out there, and you rely on the system that it works.
Dan, any follow-ups?
Yeah, I think these guys have said it well. And I mean, from a management standpoint, just ensuring that your team, keeps good records. We always try to keep a calibration log so that, something goes wrong, you come down and ask a tech and they don't shrug their shoulders and say, I think it was calibrated this month, but I'm not sure. So you want to know what your equipment is doing and when maintenance has been performed on it. And I guess the other thing that I might add is that, again, the species differences obviously have a huge factor in these things. But as an example, growing Atlantic halibut in a hatchery phase, salinity happens to be the most important parameter in an egg and yolk sac stage. And so salinity meters, or usually conductivity meters, are less consistent, I find, than some of the other water testing parameters out there. And so just having your staff knowledgeable enough to look at the animals and react to that and not blindly trust the equipment. You can put a probe in and say, yeah, it says 33 parts per thousand, but then you look at the animals and they're all sunk to the bottom of the tank because they require, the strength of the salinity to become neutrally buoyant. So obviously the animals are not showing you that the water quality is what the meter is telling you. So there just has to be some reason and logic applied to these things instead of the, the blind trust that is so easy to fall back on.
I would completely agree with Dan, if I can add that. pH is a good example in our facility. I'll check the pH and it'll be off. It's not that the pH is off, it's that the calibration needs to be done. And that's for a lot of the equipment that we have for testing.
Okay, to follow that up, what do you do when you're in a situation where you find yourself doubting your monitoring equipment or your test? How do you navigate through that? First to you, Pa.
Yes, of course, calibration. Check it. If it's an oxygen probe, hang it up in there, see it shows 100% saturation. If you want to check it, also go down. I think the name of the chemical Steve was asking for is H2SO4, I think it is. I don't know the English name for it, but I think that is the one that do the trick for him, so he can go down. And then, of course, it's a stationary monitoring system. If you also log it, so you have several of the same probe, you can try to change the probe on the channel and see if the failure following the probe or is on the input of the monitoring system. But just remember to do the calibration when you move around on the probes. pH, redox, CO2, other things you can do with, you have a chemical test where you can check if they're working correctly. I would say people that is not so aware of how often they in fact have to calibrate the pH if they want it on the second digit. You can say you really often have to calibrate the pH probe if you want to be accurate on that. So yes, of course, as I already mentioned, DO, air, 100% saturation, very important.
Dan, you want to follow up?
Yeah, not a lot I can add to that. I think Pa nailed it, and each probe has its protocol, and you follow it as instructed.
Steve, your thoughts from Louisiana?
Same here. I think redundancy is one of those things. I don't know if that's a question later or not, but redundancy in the systems is probably something to consider as well.
Well, you hit that one on the head because that is the next question. What redundancies and redundant practices need to exist in a monitoring system to ensure proper protection for the stock? To you, Dan, first.
So I love redundancy, and I mean, it has a cost as well, of course, but even if you have, 24-hour permanent probes in place feeding to a live feedback monitoring system, I'll still have the techs go through and check with a hand probe and do manual checks to certify that the stationary probes are reading as they should. Whether that's weekly, monthly, your system will tell you what you need there. And I mean, this entire conversation has been about the monitoring equipment, but the monitoring doesn't make a difference if you don't have something to react to the water quality going out of whack. So in oxygen's case, redundancy is king. Whether you have a low enough biomass that you're controlling it with just air blowers or something like that at the time, but you have backup purified oxygen on hand. At our system, we would have compressors creating our own oxygen and purification systems, but also have liquid oxygen backups. And you can set them up in a variety of ways, whether that's monitoring, feeding a solenoid that automatically opens once it reaches a certain threshold, or we even have it pressure based sometimes, so that once the lines themselves go below a certain pressure, the liquid backup cylinders will then turn on and start feeding oxygen in. So I mean, your emergency systems are really the redundancy that you're counting on to save yourself from tragedies.
Steve, your thoughts?
I'm good. I'll pass the paw on this one.
Go ahead, Pa.
Yes, I just agree with Dan that of course redundancy on the probe, 2 in each tank is good for the business, but no, I think in fact it's more important that we only see that in this big grow out that you have 2 oxygen probe in each tank. I would recommend you just have 1. But it's much more about the alarms. You both need to have text and a dialer, and it's not the same unit that does it. You can say you have to have redundancy on your alarm system. You say you be sure you have UPS on your monitoring system. We see so often that people forget to back up the monitoring system, even we write it on page 1, you can say, there again stands such that if you have if oxygen is important for you, you need to have 2 lines there. You have a system for the dosing and you have one for the emergency of the oxygen into the system. And remember that your emergency valve have to be normally open. We still see it's normally closed. That means when the power goes on the system, the oxygen doesn't flow. Normally open valve, okay, because then you have oxygen into your tanks. So important.
Many technicians know how to measure water quality samples and to take the samples. How do you teach your staff to interpret water quality and be able to act on that knowledge? Most of the time, this kind of thing ends up being left to management. How do you get this onto the ground level? First to you, Steve.
Well, my staff consists of 4 people, me, myself, and I, and sometimes my wife. So to answer your question, it's all between my ears for most of this. And I'm self-trained as a hatchery manager, hatchery owner. So I've been learning a lot, as I said. So I don't think I can really answer that question about staff. So I'll pass.
Pod, you want to take this one on?
Yes, I can add a little bit to it. You can say what we see, of course, when you have smaller farms is, as Steve mentioned, is quite they don't have the issue. You can say when the farm's getting bigger and bigger, you can say they start to use software where they collect all the management system on top, where they start to collect all the different values that come in, because you have a lot of values coming in. And this is to see the trends. This is to see what's going on in the farm, where you can discover things going wrong early than when you have the disaster, you can say. So yes, when they get bigger, you start to use some kind of, they start with spreadsheet and later on they do some kind of management software. We also can supply something on that, of course.
Dan, your thoughts?
Yeah, I think management software is a fantastic idea. I've been pushing that for a long time, and it is difficult to do because a lot of companies are, too small to be doing that. But really, it just helps your decision making so much in, especially in fish aquaculture. Again, a lot of what we think of when we're talking water quality is for emergency situations, but really, it can help your optimal growth, your survival rates, things like that on a long-term basis as well. And in terms of the technicians themselves, again, experience is key, but also just like using their senses, being as in tune with the animals as they can. So you take all these measurements every day, look in the tank while you're taking them, so you can see how the fish are acting under these certain conditions. And then you will start to see when a change happens, how the fish react, or how the tank looks different, and these correlations start to become causal, and you'll start to realize that the longer you're there and the more results you see from this.
How does a farmer protect their stock while they install and learn new monitoring or testing devices? How do you get these things set up while still maintaining your monitoring as you're learning a new system? First to you, Pa.
Yes, I think it's something with technology, you can say, because all the farms often start with having some kind of handheld equipment, you can say. So you start, for example, if you think oxygen is important, you have a handheld that you can go and measure the oxygen with. So before that, you had nothing. Now you have a handheld. Then later on, you in fact discover that you want 24 hours monitoring of it, and then you install the system. But you still have the handheld equipment while you're installing it and learning what's going on, you can say. So I think, in fact, it's just a easy answer, because you have the handheld already, or should have a handheld, because the handheld will always help you understand what's going on. You will not monitoring your whole farm. You will always have transportation tanks or stocking tanks that you only temporarily use and so on. And now the handheld will help you to monitoring that. So I think handhelds in some kind is the way.
Go ahead, Dan.
Yeah, I would agree with that as well. It's a great way to get started. I think in terms of, kind of growth and development of a company as they get bigger, again, very species dependent, but if you're looking at the total value of a tank, it changes rapidly as the biomass increases, obviously. So I think kind of to a point earlier that Steve made, I experienced this last year when I shifted from Atlantic halibut into oysters, is that, Atlantic halibut could be looking at 4 or 5 years from the time they're going from an egg to a market. If you're looking at a turnaround of a few weeks in terms of like an oyster hatchery, the total value of a given tank is not that equal to a probe that you would justify for that tank. And so if you have to dump a tank and then restock it and try again, and you have the brood stock to do so, you have the time and space, it may be more feasible than if you lose a 35-foot diameter tank of halibut all in one shot, and that's enough to kind of sink your quarter. So it is really determined by the value of the tank or the system. So I mean, we have some smaller research systems where we wouldn't put a probe necessarily in each animal housing tank. We just put one in the header tank of the system, and that will give us an indication of the rest of the tanks and the health of the system.
Steve, your thought?
I agree.
Okay, thank you.
Welcome.
Okay, we're going to move to the audience portion. We have but one audience question here. What tips can you give to someone just starting out and trying to establish a monitoring system in terms of the choices they make and how to choose a provider? First to you, Dan.
Well, I won't say how to choose a provider because Pa's sitting right there, but I will say that there are a few companies globally who do extremely good work, and I've had experience with lots of them. But I guess one thing as an operator that I would recommend is that if you can get an understanding in-house of even simple stuff, whether that's switching a probe out and putting a new one in so that you can, test if it's the electronics that's a problem, or if it's a sensor, or if it's your monitoring system. Even stuff like that in-house is so valuable, because once you have to go to the provider for help, your turnaround time of solving that issue is a little long. And that's not the fault of any of these providers, it's just the fact of life right now. And so, I mean, going into this, I'm a biologist. I know nothing of electronics or engineering, but I did have the pleasure of working with a gentleman who did have a good scope of this. And so if you can get a basic understanding of your, 4 to 20 milliamp kind of monitoring stuff, or basic PLC input output, I know it's kind of overwhelming to start with, but it can really help your overall growth for the company and for your monitoring systems. So I do think that it's something that's kind of overlooked in the aquaculture world and just kind of pushed aside to, someone else takes care of that. If there's anything you can add in-house to that, I think it's valuable.
Steve, any thoughts on tips for startup and creating a monitoring program?
I think it depends on the species again. If it's going to be a farm out with halibut and big tanks in a closed recirculating system, or if it's the hatchery of that very same species even, those are the types of things that need to be looked at more closely, and approach people that have experience, especially in rearing those, if they're willing to share that experience with you. That's one thing you'll see amongst commercial groups. There's a lot of proprietary information, or so they believe it is. And so oftentimes you never find out someone's having trouble, and you never find out what may have actually helped them out in that particular instance. So as an industry as a whole, it's a detriment, but monitoring equipment may actually help with if you can get someone that's experienced to share that information with you, not necessarily the salespeople that are trying to sell it, but have something to back up why you should purchase a particular monitoring system for your particular species and the stage at which you're trying to sell product.
Pa, the final word today goes to you.
Thank you. I can say, of course, buy it from us, you can say, but in fact, I agree with the two gentlemen, you can say, and I think that the important part is don't build it yourself, you can say, because you should take care of your fish and you should concentrate about that. If you want to build a monitoring system, they are so cheap today, so you will not even earn that money back, you can say, and then you should try choose a supplier that have been in the market for at least 10 years, you can say. They're reliable, they will also be there tomorrow, you will still be able to get spare parts, all that kind of things is quite important for your monitoring system, because again, it's your investment. You invest those kind of money and you want to be sure that they also are there in 5 years. So just try to find a supplier that in fact you can see a record of, and then if we talk about quality on the measurement, that in fact don't buy it from the cheapest one, and you don't have to buy from the most expensive one, but there are something with quality and price here, and especially for some of the measurements probe or the probe you need, the accuracy on that, and if they are even reliable, also have something with price to do. So just find one that you think is reliable and will be there also in 5 years. You couldn't
Well, thank
choose
you very
us.
much. Thanks very much, Pa. Unfortunately, time is our enemy, and we've come to the end of today's session. I'd like to thank all three of our panelists for volunteering their time to share their experiences and help forward our industry. Also, a big thank you to our friends at OxyGuard for sponsoring this series. Thanks, everybody, and take care.
Thank you.